Okay, so welcome to cross-organizational data collaboration number 6. And today I'd like to just see the conversation, who knows where this will go, with a LinkedIn post that I read the other day that I'd like to get everybody's input on. I think it is entirely central to a lot of the things we're talking about and a glimpse of what could be the future for knowledge sharing. So let me go ahead and share my screen. And okay, so this post was shared by Bart DeWitt, one of my connections. He's very much involved in this idea of open AI and open algorithms, and especially as it relates to what's going on in the EU and how they see it. And he shared a post about IBM, my former employer, actually his former employer too, and how they're kind of switching gears. So what it talks about is that this year was the first year in, I think, 20 years or more that IBM is not the patent leader. I think Samsung, who's always been number 2 recently, has eclipsed them. And the big news is they don't really care anymore. This is not a thing for them. It used to be. I remember working quite a bit on patent groups, patent innovation. It was a big part of their portfolio. And I do have to say that a lot of the submissions that we did and some of them that were actually accepted were, they didn't have any immediate utility or even anything that we could approach putting towards a product that I saw in the near future. They were just kind of to make our mark there and see what we could, add to the portfolio. That said, they're kind of shying away from this. And this is what they said in this article. Patents are only one measure of a company's true capacity for innovation. IBM will continue to patent new technology, but patents alone are a more incomplete barometer than ever before. Now, here's where I think it gets interesting. Balancing trade secrets and patents alongside a style of R&D called open innovation, in which teams from various organizations and institutions collaborate with both internal and external players. They share knowledge openly around well-defined problems and communities. Now, that's interesting to me, that they're starting to recognize this. And I suspect that actually Red Hat is eating IBM culture from the inside out. This is where this is coming from. I could be wrong, but I think this is what's happening here. But this is the tack that they're taking. And then there was a really good comment here by Ariel Beery, who says this: the development of generative models means new approaches around patents can be developed faster than ever before, in many ways overstretching the resources of the would-be monopolist. In an area where multiplicity is near infinite, the provision of the product or service that provides value becomes far more important than the formulation of that product or service. The implications of that shift require businesses to rethink their emphasis and should drive policymakers to rethink how we grant public monopolies on inventions. So this idea that the tool or the idea that you brought forth to provide a service is becoming less important than maintaining that service and evolving it. That's how I read it. Any thoughts on this?
Just immediately, you triggered something, because I'm thinking that knowledge graphs, for example, could be a distribution mechanism for provisioning. And so if you go to YouTube, there's a video with Bob Metcalfe, the pioneer of Ethernet. And he was at places like Xerox PARC back in the day, 50 years ago. Anyway, Metcalfe talks about networks of networks, different tiers of networks. And of course, that encompasses not only the physical layer and the data layer and the app layer, but he's also thinking in terms of people and buyers and sellers as a kind of network. And so the more you harness Metcalfe's network effect with the blending of all these networks together, the more powerful you become in the in the aggregate, so to speak.
Yeah.
So if you can find ways to make products discoverable and then have the means of making them discoverable, that's as valuable or more valuable than the product itself. That's just an initial thought.
I agree.
Alan, I think you're spot on. There's been a whole bunch of books actually written on that, but the key to success that people see more and more is this notion of an ecosystem. And so one of the things I should probably mention is, and Andrew's kind of overlapping in my climate work a little bit, but one of the things we're doing, I work for a volunteer basis for an organization called OS Climate, nonprofit, but it's sponsored by a whole bunch of these huge insurers, asset managers. Anyway, long story short, they're trying to figure out how we can make climate data easier to share, consume, find, and trust. And there's four things we're trying to leverage that are out there already. And I think the reason I'm mentioning it, I think that to answer the question around where things are going, I think there's four things that we're seeing that are directly applicable. One is we need to be able to leverage we need to learn lessons from folks who've done it before. For example, Creative Commons that allows us to share ideas, open source software licensing, share software, open API specs, for example, share contracts that define how things interact. And what we're trying to do is create also shared data through marketplaces. So we're doing all this in the context of a climate data ecosystem. So that's a bunch of things, but it's a UX that allows people to publish climate data. It's a UX that allows people to find and consume data, but it also has critically the things that are gaps in most ecosystems. But I think directly applicable in what this fellow mentioned, Bart mentioned in Andrews, you highlighted, is we're introducing under that umbrella climate data licensing. So being able to, again, apply some of the ideas that we learned, the lessons learned from other areas, but maybe apply some version of the Apache or MIT licensing to data. We're also talking about introducing explicit service level agreements around the availability of that data, and climate data contracts that explain, how do you actually go and acquire that data? How do you move it around and that type of stuff? So there's a whole bunch of things that were on the climate data front, because it really is an ecosystem. There's no owner of all that data. In fact, there's hundreds, if not thousands, of owners of the data. So really, the question is, how do you best bring those climate producers and consumers into an ecosystem? Well, bottom line is it's more than just having the data there. You have to provide the ability to share it, licensing, the ability to trust it, so service levels, and the ability to find it through a marketplace, and the ability to actually understand the format and structure of that through data contracts. So that's where I see. And then obviously knowledge graph is an element that supports a bunch of these capabilities. But that's where I see something really big. And with my clients, obviously I'm helping this, and it's an external data environment, but all of my clients inside the enterprise are also talking about this data ecosystem, and how do I allow independent producers and independent consumers come together as kind of the next generation data strategy.
I think there's comments on this. Maybe I agree that for data in particular, I would say both patents and full openness is not really viable, okay? Because you will need licenses, you will need one topic I've been working on is how do you share revenues if you, in that ecosystem that Eric just described on level one, you have people bringing in data and other organizations using that data. How to share revenues is typically a problem that I think patent and also fully open models won't solve. But back to maybe, and second comment, okay, back to the maybe opposition between patent and open innovation. I would say open innovation has been rising for quite a while now, And I think we should not oppose or really say that will replace patents. And as many times, I would say it depends. Okay, it depends on what kind of thing you want to protect. If it's in the digital world, if it's a service, then I would say it's likely that you will put a focus more on speed. And for this, maybe open innovation will increase or help you increase your speed. But in some cases, patents are still there to protect you, and especially maybe protect your upfront investments. Okay, I'm working now in the automotive industry. When you launch a new product and you plan to sell hundreds of millions of them, you have to build plants for this. So it's a kind of huge upfront investment, not only in R&D, but also in manufacturing process. It's a good thing to get an insurance, okay, that somebody that is maybe faster than you will not just take your ID that may open there and build the product faster than you. So I think organization need both, okay? But there is for sure a rebalancing. It's not only patents.
And this is the whole idea behind patents is basically to protect, exactly as you say, Olivier, the original invention. But as the movement and the speed of innovation is so rapid, especially in the software, where you can create new things and you don't need to do that background research in the same way in many cases. I think that the patents will probably diminish in value. But for the industries where you have a lot of research, like pharma and other, where you cannot really spend that money unless you know that there is a chance that you actually get the possibility to sell the product in the end. So I think depending on industry, it will change rapidly, but it will continue in software to go more and more, I think, into open innovation, because its speed to market is more important than getting it down into a patent.
Yeah, no, I do agree that there should be a healthy mix between the two. I think historically, though, most innovators within companies, their default reaction was to say we need to protect our IP, and whether or not it was IP is in question. There could be duplicative efforts across companies that they don't realize. And then one other thing that Ellie Young brought up, I wish she was here to talk more about it and dig in, but she was on the podcast of Ashley Faith, and she mentioned something that she noticed which was that oftentimes you think that when you come up with an idea and you start fostering it, that if you release it out to other folks, that they will somehow steal it. But more often than not, the path that you took, combined, interlinked with the problem set that you're trying to solve, is so contextual that people often don't even understand where you're coming from. And it's only later that they get bits and pieces of it. So that combination between the problem solver and the problem trying to be solved often isn't even obvious to people. So when you put it out there in the open, they may get glimpses of part of it, but that uniqueness, that fingerprint of the problem resolution somehow is enough to allow you to foster it even out in the open, and it often doesn't even matter. Then most people aren't even going to attempt to do that. And I thought that was interesting, because sometimes that is true. You think that everybody is inside your head and that would be obvious to them, but often it's not. And sometimes you may get a collaborator that can help you along the way to achieve your actual goal, and that's your intermediate goals, which is the problem at hand, possibly.
Yeah, I think that's a really good point, Andrew. And I was talking to somebody last night who seemed to have a lot of good ideas, but he was very guarded about what he was really conceptualizing. And it was obvious that he just needed to brainstorm a lot with people who are actually more technical than he is, to try and see, what's in the realm of the possible here. How could we build a minimum viable product out of this? I think he's just shooting himself in the foot by keeping everything secret.
I think it goes back very much to the idea is usually the small parts of it. Execution is 95% of bringing the results in place. But sometimes the idea is really important. And if it's a really unique one, then maybe. But in most cases, it's really about driving it, and that is hard enough in most cases. The idea is, yeah, it's just something to execute on. So I think it really depends, but in most areas, and we talked a lot about speed, and I think that speed is the one determinant factor. So if you have the size enough to drive that speed, it's probably more important to get that done. Get it out.
Seems like you've thought a lot about this, Philippe, and I'm wondering, maybe you could give us an example with what the SaaS product that you've come up with and what your thinking is along those lines.
Yeah, it's and it was a choice. So really much, and how will I be running it in the open, or will I actually drive it myself? So there was a choice to be made, whether to open source or not. And I'm still not done with that choice. It might change, I don't know. But the moment I realized that putting a UI on top of something that is open, like Terminus DB, will help the community. And I know that I can drive a lot of that execution in different realms on my own. And there are a lot of thoughts around the future that is not yet shared, for the longer roadmap that I can still execute on in a good way and fast enough that I know I'm ahead of the market. How that will change will definitely drive different decisions whether to go open source or not, because that might go faster and go better. So it's very hard to think about it. And I have previous experiences as well. Back in 2001 we ran a dual factor authentication business, and we went the patent route. It was so much work and so much to figure out that we should have. It was a very small business. We should have spent all of that time building the product and going out and actually creating something out there. 16 years later, my partner from that time went to market very successfully with it, but he had spent 15 more years building that product. And had we done it together, we would have gone much faster. So I think it's really a choice to be made in the right circumstances for the right reasons. When you have a lot of, like in pharma, you have a lot of investment to be done. But if you're working on your own in your own time, I don't know, many times I don't think it's worth it. It's better to go fast and go into the market and learn from experience and learn from how it's perceived. Bringing it to market, getting the feedback, iterating.
Yeah.
That is what I see. Getting out there, get the feedback, and iterate it. You usually don't have the perfect idea from the start. It's a good starting idea, but it will pivot in so many ways before you're done.
It's a really good way of saying it.
So in the chat, Kevin posed a question. He says, other than the Red Hat model, how do you make a living in open source? A maintenance model is very expensive. Interesting question, because many people have asked this. And we've evolved to open core, and sometimes you don't make money. Some people do. Red Hat had a unique circumstance in that they were the kind of first mover, and it allowed them to capture a lot of that, operating system distribution for Linux, but that couldn't be duplicated, obviously. Any thoughts on this?
So is it volume that really made Red Hat successful, given that the margins would be kind of thin, I'm guessing?
Well, from my understanding, like you say, it was first mover. And, I did some work for the government where we built free software that we would give away to the states and everything. And what I found is that the states wouldn't buy it unless they paid for maintenance. The university wouldn't buy it unless they paid for maintenance. And the cost of the maintenance, doing the contracts for the maintenance in the government was more expensive than I was charging for maintenance. So they told me not to ask for it, give it away free, which I'd already done. So now Microsoft is promoting Ubuntu rather than Red Hat. So if you get on Azure, they're going to give you an Ubuntu environment. So, when you have an open source, we can fork, this whole question of how to make a living and, building systems that were widely distributed and doing the maintenance and the quality assurance and the user support is really costs a lot of money. QC costs a lot of money. Testing costs as much as development.
But here I think that there is it's not an antithesis in my world to go with open source, because what you have is, when you're an enterprise and you want to buy a product, or you want to use an open source, you need the trust that there is someone there to take care of you, because you won't build that knowledge yourself. And so what you're doing in open source is that you're building a lot of knowledge into something that only you can understand. There is a small team that really understands it, and you will have a few people outside of that. I think that goes for data as well, which is why I think that this thread is interesting for the data world as well, because there will be very few people that understands how the type goes together, the ontology, the taxonomy of the data, and how it's really built up and how it's intended to work together. The same for software. When you really understand the core, there is no one that can compete with you. You have it in your brains. With AI, that might change, but I don't think it will change that fundamentally, because you have a roadmap that you're sharing. You have a direction. You want to take it somewhere. You understand the market. So the trust, the support, you have someone to blame is an important part as well in an enterprise. You want to say it's their fault, not our fault in the end. There wasn't this VP that brought this product in. It was actually a company that sold it to us. We paid for it, and it's their fault. That's an important one. And I think that less hassle is a key part in open source. I don't want to run this in my own backyard. I want someone else to do it, and I want an SLA. I want them to take care of it and just have it there for me, so I know I can get updates. And the same goes for data. I want the updates for the data. I want to know it's accurate and good. And if something is wrong, I can blame them. It's their fault.
Agree 100%, Philippe. The biggest problem or biggest challenge in these ecosystems, so I build these for my clients. A lot of them are internal, and a few of them are actually external facing. So I build these ecosystems. So we're an ecosystem company, I guess. But the biggest challenge is building your network. And that means building the folks that create the producers that create the stuff. In our case, the case we're talking about here, the folks who create the data and then make it available. Then the consumers who actually want to consume it. The challenge is if there's no consumers, nobody will want to create the data. If there's no producers, there's nobody that's going to actually be able to consume anything because nothing's created. The whole thing around that is developing. Understanding that your first job is developing the network. The software is a distant, I'll be honest with you, it's a distant second criteria. So if you want to get into the network, the ecosystem game, it is all about building the producer and consumer trust and getting them to actually participate, showing them that they can actually make money or achieve a purpose out of it. That is not simple. That is the hardest part. So anybody who's tried to do it, and I've done it a few times, failed a few times, it is not easy. And there's a lot of nuances to actually being able to do this well. Software is a distant second in making it work. It's a necessary, but it's absolutely not sufficient. Now, one of the things that we focus on, two things actually. One is trust is, first, second, and third is actually trust. And that implies a whole bunch of things. But the fourth, if you want it, the other priority is ensuring you have an outstanding user experience. If your users are data scientists or developers or whoever, big banks or little banks or insurers, whatever the case may be, your users have an outstanding, and I mean that very clearly, an outstanding user experience. Anything short of that, you will not get the folks joining your market, your ecosystem, your marketplace. So those are kind of some lessons learned. And we're applying this with this whole climate data ecosystem, all of these notions, and the fact that it is not just about the tech, it's about all the other things that need to come together. And the last thing I'd say on that, do not underestimate how difficult and time consuming that actually is.
Yeah.
Yeah, Eric, it's actually interesting you say that, because the guy's post that I mentioned, Bart DeWitt, said that to me in a conversation. I asked him, I said, well, what sort of technology would you use to share these AI algorithms? What would that network look like? He goes, I don't know. He says, in fact, I don't really care right now. He says, I'm trying to build a community. And he spent the past 3 years talking to pharma companies, socializing it, talking about the value of being able to, why it's good for them, why it's good for each other, for them to share these algorithms and why it's good for the patients ultimately. So that's all he's been doing. His whole initiative is around building a community to this day. Nothing about tech. So that's interesting.
Yeah, so that is
I think-
somebody's point. Should that person be focused on, keeping their technology closed? If they're in the network game, it's an irrelevant question. If it's closed, or open, it doesn't matter. The technology will follow the needs of the community anyway. And trust me, the other thing I know, the community has, what you start with is not what you end with. It is very, very different what you think the community wants with what they actually need. So whatever software you have now, I mean, you might as well just give it away because it's secondary in consideration. Anyway, that's my experience.
Yeah.
And I want to continue on that. I think it's a very important part of the network, the consumer and the producers. That is the value, the connection, the trust between them. If you manage to create that, you've created value. And as you say, the software is irrelevant. You can build another software or bring in something completely different. They will still trust you no matter what you do to provide it, because you've done it once, you will be able to do it again.
Now I know Alan has a few questions. I'll just leave one last comment. There's a lot of examples of this. Airbnb. So all the time, every time I talk about ecosystems, I talk about two things. One is Airbnb, and then I talk about the Uber experience. And it is like I said, if you have one driver, you're not going to have people knocking on Uber's door. But if you have lots of drivers, they help you cover the network in the city, and you all of a sudden you have an ecosystem. Same thing with Airbnb. You got to have both of them coming together. So the interesting thing about this, there's lots of examples out there that you can actually use to communicate the concept. Yeah, Alan, I think you have a bunch of questions.
Yeah, and I didn't want to steer the conversation in another direction, so I put it in the chat. I just think that Eric, your discussion of the climate-related ecosystem, something I've been talking about with Ellie Young as well over the years. And I think one of the most compelling things about the data-centric architecture approach is that you've got this model-driven development opportunity with it. And so the ontology can be the vehicle, the ontologies can be the vehicle for that model-driven development. But it's such a left turn for people to try to think about how that could work, that, there's just like the people who understand that and how to do it are as scarce as hen's teeth, and they're just getting buried in the noise. So it seems like a great opportunity to just put the resources there in the graph so that people can grab them and use them, and really just write the executable logic for the apps that they're creating. It would be a much less complicated scenario, but just getting to it somehow just seems very problematic given the nature, how different it is from how people are used to developing.
Could I give you a paradox or a different point of view, which the context, I worked from 94 till about 10 years ago on building something called the Data Web at the Census Bureau. And what I did is I built a metadata database. It's basically data dictionaries that would allow you to query servers all over the United States. And it had most of the census data up, had a lot of the CDC data up, mainly government data. It had Health and Human Services, Bureau of Justice data. I don't know how many thousand data sets we had. And they were all not only aggregate data sets, but they were what we call microdata. They were actually survey responses or business transactions. And they would tabulate the data on the fly in about 2 seconds. And we could lay data on top of other data. We did a thing where we took police report data from Memphis, Tennessee, and integrated an Esri server with our own open source mapping server. And linked it to decennial data where we mapped the perpetrators and the victims' neighborhoods, and then where the crime actually happened, and mapped the whole thing in about 3 seconds. And so we had this, what people here might call an ontology. We didn't really think of as an ontology. What we did do is we spent a lot of time on trying to get, with aggregate public use data, the variables to match. Geographies change every year, and trying to be able to look at the same data back in 20 years so you could on the fly create a time series. What we found was something kind of strange. We found that anytime I build an interface, somebody would want something else, because the data is not a unidimensional issue. A data is like going to a pantry and a nice chef's thing. And every chef is going to make something different from it. I remember going to a conference and I didn't have any environmental data up, right? Because I was dealing with economic and demographic data, social, cultural data. And I remember going to an EPA conference and they said, how come you don't have watershed data up? And I said, because we have towns and cities and all that kind of stuff. He said, and I said, well, really, the air and the water really isn't something that census deals with. And they said, well, think about it. Who causes all the pollution? It's the people. He said, if you don't have demographics, economic activity with environmental data, it's worthless. It's like another gotcha, like no matter what I did. But what I found is that data is an ingredient. And going back to your issue about interfaces, we worked really hard, came up with lots of interfaces. And every time we met somebody new with data, it's different from other things. If I'm a report writer, data is an ingredient, but really the product is the report. If my product is data, then every possible report is a possible product. And what we ended up doing at Census, I sponsored the Census API. So my team actually built the current and still building the Census API. And the thing, it was really great. You could get the data, but you don't get the average person going to that. You only have developers going to that Census API. And only the interfaces that developers choose to give to people do they have. So what happens is, my goal was to have data that would allow you to look at a newspaper and say, let me see what's underneath that statistic. Is that unemployment really telling me the truth, or is it just telling me kind of what they're spinning? And so I never really got, we actually built a report writer that you could drop and drag your own dynamic reports, because we found that the other thing about data is nobody cares about data. That was a hard thing for me to learn after working on it for 20 years. All they care about is answers. And reports are closer to answers than they are to data. So even though data might be the fuel, nobody drives around gasoline, they buy a car.
But I think there are some key points in what you're saying as well. And I think that between those lines are another few key points that, Alan, you've been putting it in the chat, but they have been in my thoughts going through this. I can go back to an HR system I helped a client with back in the day. It was one of those generic databases, embedding just about everything they needed in terms of HR data. But it was built a hopscotch of things. No one understood the thing because there was no typing. There was no information about how the data was there. All of the data was there, but what it was and how it was interconnected, no one knew. I think that is the core of the problem, is that we're so used to not having the type definitions. We're so used to having the ER diagrams far away from the database. We're used to having the UML diagrams in some paper that someone forgot in their drawer 3 years ago. No one knows where it is. Nowadays, it's a bit better. We have them on wikis and other places, but still, the data about the data, the metadata is far away from the data. We don't know what is there, so we cannot build anything from it. And so taking this model-driven approach, I'm thinking of a call I had recently where I talked about a model-driven approach for applications where you build thinner apps on top of your data, where you know your data, what your data is and what you can do with it. And so suddenly with the model-driven approach, you can do that, but that is the immediate outcry was heresy. This is not possible. This is insane. We cannot do that. We cannot have the logic like that. It will just break apart. It's not the way to do it. And that is because we're used to the paradigm of databases that have a structure that we don't really know anything about. They're just loosely connected. So changing that entire paradigm of not knowing what data we have in a database by their structure, we only know superficially what is there. We have an idea more or less, but the descriptions are missing.
I'd love for somebody.
We change into something where we have, oh, sorry, when we know how the data really works and how it works together. And I think as well, embedding the logic in it in terms of how you can use that data and what is permissible and not permissible, the world will change quite rapidly.
We built something along lines of what you're talking about. I had a long background in relational databases, even moved into object databases, et cetera, UML, the whole. But what we did is I felt like people didn't understand databases. So somebody can use this idea. This came from somebody else. I basically built a thin SQL-like interface. And so we access SAS data sets, we access SPSS data sets, we access C flat files, we access DB2, Sybase, we access data, in Hadoop in the later years. So we abstracted the whole data structures away from the user. So all the user was looking for was just variables, So they didn't have to understand how it's stored. We handled all those different kind of data, and it was a real simple idea. When the server came up, it had knitted, and it knew what kind of data store it had underneath it, and it built this abstract query layer over top of it. So everything was the same, no matter where you ran it. The problem was, and this goes almost to an ontology problem, is that a lot of the data that we get as statistics out of the Census Bureau, for example, are things like unemployment rates. And I don't know, I'll kill that. Anyway, and so most of those data things are transformations. And it turns out there's very few people that understand those formulas. So what we spent all our time is trying to put into the metadata, the formulas for the transformation. So when you look for unemployment rate, it would dynamically get it from wherever it came from. And the big problem is you'd also be linking data. Understanding how to use the data is right now a human expertise problem, and how to encode that is a problem. Anyway, that's all I had to say.
I think what you have just described, it's the difference between maybe the underlying data, let's say maybe sometimes the database, and the data product or data services. And I think more and more, and you see this in the data mesh trend also. And this is my own experience, okay? The value of data and especially in ecosystems, in cross-organization, it's not a database, okay? It's really the data service. So it's because this is the contract, and this is the way to formalize things. So expectation regarding data. And also in my experience, because we started with IP, with trust, okay? Trusting a database and trusting a data access service, it's really two different things. The definition of trust, because it's not something that is fixed, okay? So the life cycle of the thing is very critical. And on top of this, when you add AI to all this landscape of trust, and I'm requesting this, or I will consume something else, you have been talking on AI AI algorithms and opening AI algorithms, but in reaction to this, I think you would need to define what you mean by AI algorithm. Is it really the learning algorithm? Okay, that is really open source. Why no? Almost everything is open source, but it's not. It's this thing as really. It's not the value, okay? Because when you will use AI to create something from data, most of the time, what you have is software, but this is not an open algorithm. And in the trust topic for this around, I don't know, federated learning, around maybe recently, okay, you have this generative AI, they are copying things, okay, and we started with IP today. And when an AI we learn to create something by observing things that may be protected. Is it stealing or not? Okay, so in this landscape, when you add in this landscape of collaboration between organizations, when you have software, AI, software data and AI, really, I think it's really things are not really clearly defined right now. And this is a huge topic of awareness, understanding, and new legal topics, new questions like this about ownership, about right to use, about licenses. Everything will be redefined.
But forgive me, I'm for being selfish, but I love this conversation because it's dealing with something that I struggled with and no one warned me about for 20 years. And what we tried to do back then was essentially take the metadata and make kind of a lightweight, old-fashioned expert system with it. Put the business rules for using the data and store them with the data, because right now everybody stores the business rules in the application, in the interface. And the idea is if you could put the knowledge back with the data, then every interface could use that, no matter when they build an interface. Today, it would be beautiful to build ontologies using AI rather than human being experts doing that. It'd be great. The problem is, for me, is where do you get the training set? How do you train it? If someone could figure out how to use people's use of data and start out with some rules and then store those with the data and then build an interface builder, because again, people want reports, they don't want data.
Yeah, one of the things we've done on the climate side is we're looking at not just data, but actually algorithms and even eventually models. A lot of the climate data is available in these PDF reports that companies send out, which are just plain simple, English text in paragraphs, it's not structured at all, in fact. So what we did is some of the folks used natural language processing. And what that allowed us to do, you can get pretty sophisticated with this stuff, but simplistically, it allows you to find the major nouns and subjects in there and kind of get you a list. So we use that as a starting point to actually assess what are the key topics that folks are highlighting. In the old days, we used to get these word maps and stuff, but you get the idea. The other thing I comment, just kind of lessons learned, is even within an enterprise, what we did is we used this notion of crowdsourcing. And the primary thing was we said, when I started early in this area, we had this central group that defined the ontology, the glossary, and all the functions and capabilities that we knew everybody actually wanted. We quickly found out we weren't very right. we were partially right, but very quickly we found out that we weren't hitting the mark. So what we ended up doing was take a slightly different approach. And what we said is we're going to allow crowdsourcing. So in an enterprise, what that really meant is we're going to provide this marketplace and we're going to allow you to publish your own stuff. Now, in an enterprise, you have a degree of you can mandate certain things, you can declare, standard nomenclatures and such. So in an enterprise, you can actually, guide that a little bit. But ultimately, what you want to do, and what we found very powerful, we did this with an API platform. We just said, look, we're going to provide the portal and we're going to provide some basic kit that is better than anything you could build, but it doesn't cover the business functionality. It lets you do logging, alerts, all the security stuff, these cross-cutting concerns. So as long as you use this standard toolkit, which was better than anything, we made sure that, our job around putting the platform together was fantastic. We said, look, you guys build the APIs, and you're going to build it based off of the needs that you see, but hopefully you publish it and other people will begin to use it. So even inside the enterprise, we use this notion of crowdsourcing. Kind of it's kind of funny because the first thing, the comment that came out from the enterprise architecture team was, we can't let this, the analogy they use is, we're gonna have 1,000 flowers blooming in the field, but there's also going to be hundreds and hundreds of weeds. And we said, well, that's okay. Somebody's going to prune them by not using them. And eventually they won't be funded. But the ones that do get used, we're going to find out, where we actually invest. So yes, it's not as efficient cost-wise, but it is very fast and agile. So we wanted to prioritize agility and speed as opposed to, cost optimization and standardization. So truly, we did have 1,000 flowers blooming, and some of them were not all that standardized. But we actually knew what was a priority, and then we had a chance to start to normalize. We're doing the same thing in the climate data, mostly out of necessity, because we have no mandate to own any of that data. There's thousands of owners out there already. So our job is to figure out how we can make it really, really easy for them to publish stuff into the ecosystem, i.e. 100% crowdsourcing is the model that we're probably going to land on. And that's, again, the kind of the lessons learned that unfortunately I couldn't give you earlier as you're building your census stuff.
But I'm thinking there's an interesting part here, because if I try to summarize what we're saying is that data is one thing, the typing of that data and the structure of it is very important, but making it into either a report or an API or some other consumable or producible way to produce it. So that is, there is a layer that is fairly thin. It's not that extensive to build an API that you can trust on top of data. You cannot, the idea is that we cannot trust the data that much, but we can trust an API because that is a contract on the data that is behind, both for writing and for consuming it. So you have some standard mechanisms in an API for how to work with the data. And usually those functions are fairly thin. They can be stored procedures, or they can be written in some language. And you see them all over the place. They're fairly thin, but they give you the contract. Standardizing on those contracts would be a very interesting thing when you're trying to connect the knowledge graph with types. So that you have a constrained knowledge graph, you have the data in it that comes to it, or that is in it, or that is consumed by it, and you figure out the API parts of that and make that consumable as well, or updatable as part of the product. Suddenly you have something in data mesh that is really interesting in its own self, because you would have also the API codified in a way that is shareable, manageable over time in the enterprise. Because as it is today, we're creating these APIs in 150 languages, and we're really just reinventing the wheel every single time for, as you mentioned, Eric, for a few basic constructs of security and logging and audit trails and role-based access control and whatnot. We have a few standard mechanisms that need to be there. We all know more or less what they are if we are asked for a list. So why is it that we are not able to actually commingle that with the data, the typing of it, and the logic of it? Because the logic isn't that hard to build a logic contract for the data in the data product. This would be an interesting thing.
Yeah, I mean, that's the argument I was making in the chat exactly, Felix, is that digital twins are an alternative to APIs. And they allow this kind of description and discoverability that REST was envisioned to allow, but never did really. And so if you just think about twins, microtwins, as a reusable, discoverable, standardized kind of API, then it helps you get into this mode of creating things that aren't in 150 languages and can't be reused.
You said I want to react on the APIs and data, and maybe Philip, you said is the API trustable means that the data is trustable also, and if it's so, if my understanding is correct, I disagree with that, and I have an example. Let's say you want to, your service is a service that says you ask for a position and please give me the speed limit, okay, on that road right here. The API, it's very simple, enter coordinates, and then you have a result that is the speed limit. And it really depends on what you will do with this, okay? Because if you test this only as an API, you will not see what's really important in some cases. If you want to build a car with automatic driving, okay, that information, that the speed you got from the service is really critical for safety. And then you really need to define the data that is returned, is it trustable or not? And I said trustable because the ground truth, okay, I think you cannot define and you cannot test whatever the number of API calls, okay, in your test plan. You cannot test that in every car in the world, your service will return a speed limit that is maybe true or maybe safe, okay? So that definition of trust, safe, and you can use it for safety critical applications. It's really something you need to work on, and it's not linked to the technology you have, the API, or even the data sources, okay? Because just that in the world right now, you don't have access to the truth. So you're creating a sort of, I don't know, not really
Proxy.
a digital twin, but you're creating something in the digital world that will help you steer things in the physical world. And final thought. I really my conviction about this is that we need to focus on the quality of the data. We need to agree on okay, what is trustable data, and not only a trustable API.
You're speaking to my soul here, in that, again, I work with government data. So the data set, the official data set for the whole world to get the unemployment rate is called the Current Population Survey. It goes back to 1946, right? It's done monthly. 160,000 households queried every month, all right? There are 3 different ways of defining unemployment. They're all economically accurate. There's one that the government uses. There's nothing in the data, nothing in an API is going to tell me that correct transformation. We have multiple poverty rates. Just in terms of geography, I know that there are 3,300 counties in the United States. 2 counties changed their definitions last year. Now, if I look at metro areas, or if I look at cities, they grab, land, and they give up land all the time. It's almost impossible to look at anything over time. And, in terms of reports, nobody cares about the number 7. What they care about, if I say the unemployment rate's number 7, and somebody has a historical context that said full employment has traditionally been 5%, then they mean that we're going into a downturn, So there are 2 things. A, maintaining context and having definitions of that context. And then third, multiplying the complexity when you start using the data together. Now, traditionally, when somebody does a report, they get the 5 variables they want from this data set. They get the 5 variables they want from another data set. Oftentimes, they break the rules. They use data sets from different time periods. They say, okay, this is what housing is like over here. This is what employment. They're 2 years apart. Nobody knows that because they've just got a nice, easy to use interface. So, a fundamental issue, whether you talk about it in terms of an ontology or you just talk about it in terms of metadata, and I hate metadata. I despise it because capturing metadata costs 10 times as much money to do the metadata as to do the data. And it changes all the time, and nobody pays you for updating your changes. So, I love the concept of Wikipedia's got nothing but metadata and their definitions are always changing. Somehow they've done a crowdsource that everyone said would never be authoritative, but everyone uses it today.
Mhm.
So if you guys have any creative insights into how to solve that, because I think the point that was made earlier, we come up with these specifications and they're always wrong. Building an organic system that evolves gracefully as users interact with it is something that the literature doesn't talk about, but successful developers do understand that. And, the great insights that you
Well,
guys.
the entire space is super hard, and that is why we're here as well.
Yeah, I do think that we've talked about, if I were to summarize this, I think the takeaway that I have is that it's pretty glaringly obvious that we treat what I'll call digital knowledge, how we embody our knowledge in systems, very separately still. And we're all kind of talking around it directly. And I think Alan has put that in here. And I've been talking about this for the past few years, that data, metadata, and the logic around it, they're all part of this one thing that we treat separately, that drift apart as soon as we start developing them. And what we really need to do is start developing them as a whole, as something that's an encapsulatable unit that we can use and share. That way you don't have these black boxes. If you're using an API, you can see where the API is interacting with the data set and elsewhere. That's the metadata that's tied to it. So we have all those pieces together. And I honestly think that most of the other components, metadata and data, that logic should be operating in the context of a graph, so that every time you're interacting with some logic, that it actually is operating on top of a graph, which is then that ontology is shareable. And the operational metadata that is performed is actually stored in the graph. Something like that. The bottom line is that these three things should always be together. And right now they're typically separate, and we don't see that. So it's hard to build on that. That's why projects collapse over time. People don't know what's going on.
It's what you said to me is really brilliant. We tried to do that in the federal government. Somebody came in without RDF, and I immediately found it was failing. And the reason why was because the terminology that was used in different data sets meant different things, even though they used the same words. Like income, forgive me, this is a federal experience, but income, there's two data sets really that define income for the United States. When they figure out what's your income, they say, what's your first job? What's your second job? How much money you make from Social Security? How much rent do you get? What's your capital? How much capital your stocks are worth. Other data sets like the health data sets, we're asking people how much money you make. We really don't care about how much money you make. What we really want to know is how often you go to the doctor. If you have more money, you go to the doctor more often, right? But the word income is used in both. So IT guys would just, hey, we're going to do a graph. Here's income. We're going to do a parser. The same thing. It's income. And so I said, all the data you're going to get from that, every query you're going to get, the API will be right, but the metadata behind it will be wrong, and you'll get bad results. You'll never be able to do anything. So I love the idea of an ontology that would organically grow through a Wikipedia correction process or whatever, that would be inherent to any API query. So you bring intelligent data along, and that would be part of the API for interfaces. And the other thing I found is, in another experience, the only way you ever get standardization is by communication between different parts. That way they can be loosely coupled, but as long as they got to communicate, you're going to evolve a standard, in an evolutionary way. Anyway.
There's a need for defining things as well. As soon as you start communicating, you need to start defining things between you.
Exactly.
Any final thoughts before we wrap it up?
Well, I was just wishing Eric was still online because I think what Caps was talking about just now is it needs to be part of the ecosystem. You know, it's like how do we make that attractive to people to participate in the ecosystem in the way that he's talking about? Because you know he's really getting at the kernel of the problem there.
Well, the other piece of it is how do you, for us to get data and for metadata, we had to build a game, an incentive system, which is what he's talking about in this ecosystem, so that people would give us the rules for using the data.
Yeah.
And if they weren't incentivized, money or whatever it takes, fame with Wikipedia, I don't know how Wikipedia does it, but you know, for example, what if I built a network node here that had most of the federal statistical data? Okay, I could probably do that with friends, right? Because I've done it before. I wouldn't have all the stuff that you guys have, right? And that when you mix this federal data, like all the census data and all the employment, unemployment, all the business data, in with your stuff, the reports that came out would be much richer, and I wouldn't have the competence. Frankly, I wouldn't want to take the time to build the competence to say things that would be as powerful as what you would have to say. And the data sets that you could add to that too. How do you build an ecosystem of data providers so that people who are also analysts who don't know anything about data, but have things to say, can say it? And it can be trustworthy, it can be authoritative.
I think that comes back to Olivier's excellent argument previously in how much of that, not the technical metadata, but the human metadata around what is there, how it can be used, when it can be used, how trustworthy it can be, and in what circumstances. I think that was a very important point that you made, Olivier, that we never should forget about. What are the contextual realms around this data set and how and when it can be used in a relevant way? And that is where licensing, descriptions, and basically then it becomes prose, because that can only be expressed in the ambiguities of prose in general. I would find it very hard to identify a way to express that in technical terms so far. I don't know, Olivier, if that is in the direction of how you would express it, but that is what I got out of that, how important it is.
Yeah. At least there is. It's more semantic, okay, as we described, than linked to whatever indicator, and especially what the data engineer is saying is data good or not. And maybe it's also a philosophical question, okay? What is good data? What is bad data? Maybe for next time.
Yeah.
Well, good data and bad data is often in context of the user and the other data available, which is it's problem because it's not a absolute, it's a curse. Forgive me. It's a challenge.
All right. Well, excellent conversation. In 2 weeks, Steve Stesney is going to come back and talk about his part 2, and then we will think about what to discuss after that. I'm sure some topics will come up. This was a great one. Awesome. Thanks, guys.
Thank you.
Thank you so much.
Thank you all.